So first, I just want to thank the Cesium development team for allowing me to be here. I am very honored to be here. You all are incredible people, so I really take this as an honor, so I want to thank you all for that. And the Cesium team. Just going to give you a brief introduction. Hopefully I don't have to do a lot of talking because I have a lot of video. My name is Jeff Campbell. I'm with Project Controls Cube. We're on the west coast of the United States right now. That's where most of our work is, up and down the west coast of the United States. So we are experts in 5D planning, scheduling, cost control, VDC. We're in California. And just recently, well, I guess in the past few years, we did win the Going Digital Award in 2023. Year in infrastructure. We did just win the silver medal for the Opal Awards in 2024. And I'm saying that for a reason, because hopefully that lends credibility to what I'm about to show you guys. So we have a major problem in probably not necessarily just the United States, but the world, and that is our construction projects and our engineering and construction projects are going way over budget, and they're taking way too long to build. And it's just the interesting part about that is the larger the project, obviously, the more it's going to cost, and the less you would like to go over in terms of percent, over in terms of cost and time. But it turns out, and these are some of the key factors that I'm showing you guys here, so I don't have to read them off. But it turns out the bigger the program, when you get over $1 billion, the more percent we have overruns, and the longer it takes. So you don't want to have a larger percentage on $1 billion project, right? Because that's going to cost a lot. So why is that? Why are we in a place in the industry where we're wasting so much money in engineering and construction? It's because these projects are so complex, and there's no chance of them getting any less complex than they are right now. And that's because what we're trying to do is we're trying to connect all the dots between all of the planning of how we're going to build it, how much is it going to cost to build it, then we're trying to tie that into a 2D model. We're trying to say, have we forgotten any scope? Have we figured it all out? It's just too complex. So what we're lacking, and one of the key reasons that we're failing in the industry, is we are lacking in situational awareness. On all the programs that I've been on, it's never been the case that the people on the programs are not brilliant, because they are. They are the most brilliant people I've ever met. It's just they don't have the information at their hands to have proactive decision making. It's all reactive decision making. So that's what it used to be. That's why I'm putting that very sad face there, because we're trying to blend it all together. But what we do now is we have our digital twin where everything is combined into visualizing it. And by doing that, that's when we start saving money and time. So we're trying to get that data in real time so that we could start making decisions. We're trying to allow contractors to rehearse. Digital rehearsals is what we call them. With their digital rehearsals, they can actually test it, practice before they play, before they go out in the field. And we're also enhancing the collaboration. Even on greenfield projects, I've found that they're incredibly complex. There's still people that we are impacting. There's still the community that we have to talk to. And everybody really needs to get on the same page so we know what we're building. And the programs that we work on are billion-dollar programs, many billion-dollar programs. So how did we get to the point where we are today, where I'm able to be here with you guys? Well, it starts with kind of like the Atari age, or Sega Genesis, if you will. Back in 2024, we had to prove this concept on a $2.1 billion program. And this is what it looked like. So you can see here, it's beautiful. You have the cost up at the top. We're still able to do this in 2014. And you have what we are trying to build in different colors. That's to show, the whole process. And so we had to prove this to the team. We had one shot. We did this all on our own. We paid for it. And we had one opportunity in front of the client on this $2 billion project to see if it works or not. And this part where you can see I'm lining up with this gallery, we call this the Death Star run. You can see we're now doing the Death Star run. It's just about 1970s graphics. And right when I got to this part, when I showed them, they said, oh, we can't build it that way. The designer, we need to talk to the designer. And sure enough, 3 years later, when the contractor got on board, his first RFI was, we can't put that lid on because we have all this equipment in the gallery. So we need to figure out if we're going to do like a precast lid or we're going to put holes in it so you can see all the equipment that's in there. So thank God it worked, or else I wouldn't be here today. So fast forward, we then worked with Bentley and not Cesium yet because we weren't involved with Cesium, but this is what it looks like before Cesium got involved. So we worked and we integrated this throughout the entire $2.1 billion program. And so this is what that looks like. I started to play the video a little bit earlier, so you missed the train. So this is a digital twin of the entire site, both existing and new. And on most of these projects, we did this ourselves, Project Controls Cube. We turned their 2D, 3D models into what we call 5D. That would be the cost and the schedule. We overlaid it on the digital twin, geo-coordinates which were developed during this process, between 2014 and where we are now. And we had so much situational awareness that the program manager said, I'm tired of us knowing more than the contractor. So he said, I want to require the contractor to do this themselves. We had never done that before. So we said, okay, if that's what you want, we'll make it happen. That's really where it comes down to our partnership with Bentley, is because we just go to Bentley and we say, here's what the client wants. Can you help us do it? And they always help us every step of the way.
We now require the contractor to, tie their schedule activities to the 3D model. For them to do that in their baseline schedule, and then they review it before they then submit it to us for review. I mean, we've come such a long way. Using Synchro, the contractor using Synchro, it really made our job as schedulers so much easier. It made reviews more efficient. I would say that because contractor on TTF was using Synchro, they had the baseline that was approved in the least amount of time. It was the fastest baseline of acceptance we had on the entire program. And it was the best plan. And it finished on time. And there's something to be said about that. Every month we would require them to submit a Synchro project with their monthly update, P6 schedule, and it was great because they saw the problems before they even gave it to us. I wish all contractors did that. It would make our job significantly easier. It was a great way to end this program. Such a successful note.
When you can own that and visually see it, we found that the TTF contractor was probably the first out of all 22 contractors or the projects on site that they actually used the schedule that was developed.
So you can see when we integrate a digital twin into construction, now the situational awareness is at its peak for the technology that we had at the time of 2023. The result of this is we finished $400 million under budget, and we met all of our compliance deadlines. And that is because we let the brilliant people who run these programs, we let them have proactive decision making. The result of that is, like I said, $400 million. So what we did was that we turned around and we we made another program called the Harvest Water Project, and this is in California. So what we're doing is we're taking all the clean water that we created with this tertiary treatment wastewater facility, and we're pumping that recycled water into the Central Valley where we get all of our fruits, vegetables, you name it, that supplies the country, and we're raising the water table 35 feet. So the groundwater is going to be raised 35 feet. That's going to cost them no extra money because we use digital twins. So does it work? It absolutely works. So where are we today? Well, we today is we are taking all that we've learned in the past and we're integrating that into Unreal Engine and into this project. This is called the Bull Run Treatment Program. This is the next generation of the digital twin. What you're looking at now is world digital twins. The last one was 20 miles. This could be all of your projects all over the world, all combined. And you think that takes a lot of horsepower? It used to. Now you can see, we can see our entire projects from space, and there's no, I'm gonna zoom into it, but you could literally travel anywhere around the world and see all of your projects. Geo-referenced, geolocated exactly where they're supposed to be. Every single yard pipe, every single utility, every single building. So you can see everything is referenced into the site. This is called the Bull Run Project. It's miles and miles long. What we're able to do is tell stories now. We can tell stories to the community about how we're building these mega projects. This is Mount Hood. And so what happens is this is where we're getting the people of Portland, they receive their clean water from the watershed of Mount Hood down to the Bull Run watershed. And so what we're able to do is visually, without even having to talk about it, is tell the story of how we are enhancing the lives of the people of Portland, making sure they're safe, and doing it in a way that the community is involved. So we can show them exactly where their water is coming from, all connected to the digital twin, all live. This is the reservoir where we keep all of our water before right now it's still in construction, but before we treat it in our water treatment plant. So the fog's set here, but you can see it goes on forever. Like I said, all of your construction projects, all of your digital twins located all together. Every element of the construction project is in here, so this is a very intelligent model. We currently do not have the capabilities to harness all of that intelligence. I believe, hopefully, the incredible people in this room will be the ones that develop that. It's ripe for AI. All the information is in there, every single cubic yard, every single linear foot, the cost of everything, the duration, how much, the location, the geo-referencing, you name it. It's all embedded in what you're seeing right now. Each of these cranes represents the exact location of where they are. So you can imagine if you are a contractor who actually built this, they've been rehearsing this for over a year. They've changed their plans so many times because they found that they can improve it over and over again. What do we do in construction today? We don't even plan before we go out in the field for the first time. We just put it together, go out, and we see what happens. But now we can see everything that's underground. We could practice how we're going to build everything. And then we can work with the community to make sure that we have no disruptions, which always happens. So it's not just the construction site. It can be miles and miles of piping. Think of a project that has hundreds of miles. Maybe it's a new gas line, maybe it's a new oil line. All of that is now capable. You have the capability to do that on any project of any size, anywhere in the world. All geo-referenced all together. And it's not so big that it cannot run. It does require some power, but not as much as you would think. And I think that's the result of these cesium tiles working in Unreal. And this part is where we actually we cut into the existing water supply of Portland. Everything that you see here in the pipelines, it has windows of work, and all of that is sequenced in and visualized, so we make sure that we never violate any of the rules that have been provided to us by the city, the county, and the state of Oregon. So for example here, you can see that the writing here tells us, when we can actually cut over, these windows, so that we can visually see, because these programs are so complex, if we violate or not. And then you can see that that's where it disappeared. So that's really where we are today with the digital twin. And what we're doing is we're taking the iTwin, where it has all of that intelligent information. Bentley's infrastructure cloud is where we take that into Unreal. NearMap is the real detailed cesium tiles that you see there, overlaid on cesium ion. Now, what does that look like when you actually see it? So in Unreal, this is what you get. It's kind of intimidating for me, so I'm not as smart as you guys. So what we do is we basically fuse in all of our intelligent model that has all the information with the cost, linear fate, schedule, you name it, everything. So this is a direct representation of that. Geo-referenced, everything's geo-referenced, and then we take that and we overlay the NearMap cesium tiles on top of it. Before we had to do this one by one, but you could do hundreds of miles. And then we overlay the cesium ion on top of that. And then you have what basically is In today's world, a real world, endless distance digital twin, live digital twin. And that is the end of what I want to show you guys today. Sorry I ran out of time for questions.
Thank you, Jeff. It was an amazing presentation.